Okay, this is our last lecture. I think let's start quickly, then we can finish quickly. Not that much topic left, just two methods that left, and it may take like few half an hour or 40 minutes to finish that one. Okay, let's start our last lecture. I'm gonna share my screen. Open your Jupyter notebook. Okay, nice. I hope you saved the last programming that we did together. Okay, we're gonna work on the same code that last time we worked on that. It was linear regression, if you remember. Okay, let's open it and see what we did last time here. Okay, last time we started doing linear regression. So at the beginning, we in the line like 12, we read our Excel file, which was airfoil self noise. And for the all columns, we put a variable. Then we start create describe function and box plot for each column. We did that one, and here we did for all of them. Oh, nice. And after that, we create this correlation table for all data set that we had. We tried to understand how they correlate each other and how these attributes affect each other, okay? According to this correlation table, we got that angle versus suction thickness have the highest like effect on each other, and then angle versus core length. I forgot what was this core length. Chord length in meter. Okay, chord length, and then frequency versus a speed level. No, sound pressure level, sound pressure level. And after that, we also create a heat map. I explained that heat map exactly is same thing as this function, correlation function, okay? Either this correlation function, which correlation function actually show numerical table is all by number. And I said we have this heat map. Heat map is exactly the same thing, but just show it by color, okay? Now we understand which attribute have the most impact on each other, and now let's go and continue. We reach to the level that we want to do linear regression on this data now, okay? Let me comment it. Linear regression, okay, linear regression. And for linear regression, we have a nice, okay, first let's understand what is linear regression, okay? Linear regression is actually that line formula. Do you remember line formula? We had one y and x, and we were predicting that, okay, how y change if I change my x, okay? I'm gonna put that formula here, line formula. And what was line formula? Y equal mx plus b. Hello everyone. To view caption, please go to. Okay. So this was line formula. Y equal mx plus b. Linear regression actually is this. It is line formula. We want to find the line formula between two attributes that we have. Therefore, one of them is y, the other one can be x, and then we see how they change if we change another one, okay? How they impact each other. Here, m is a slope. You remember? M is a slope of our line, okay? If it is like going fast, slow, or how it goes, okay, up. And B was that shifting. You remember that shifting to the left, shifting to the right. If it be negative, is actually shifting to the left. And B is intercept. Okay. Intercept. Okay. B is intercept. M is a slope and B is intercept. And X is that independent variable, okay? B is independent variable and Y is that dependent variable, okay? Y is dependent variable and X independent variable. If you remember, somewhere else also I were talking about this independent variable and dependent variable. That was a scatter plot. When we were learning a scatter plot, I said, okay, x-axis can have the data set which is independent and y can be dependent. Now, when we go ahead, you're gonna see that how these two related to each other, okay? Now we got everything about this line formula. Let's go and figure out and create our line formula for two attributes that we have, okay? For linear regression, we can do it in different way, okay? The way that I do, I want to go and call one of function, which is linear regression function, and plug in my data into it, and then that's it, okay? It creates my linear regression actually for me. I'm gonna use, okay. I'm gonna use this function. It called it line regress, okay? Open close parenthesis. Line regress. Open close parenthesis. Okay. This function is from where? From which library? SciPy library. Okay. We have a library. We call it SciPy library. It is for data analysis also. Okay. I gonna import my library. Import SciPy dot state, okay, state. So from a states module, like a state module from SciPy library, okay. I'm using this function out of this module, a states module in SciPy library, okay. I want to make it short as SC, okay, I'm gonna call it SC. Here, how we use a function. So first we put that library dot that function, SC dot linear regression function. That's it. And now I want to pass my X and Y, okay? Here, we need to decide, okay, which one can be like the X and which one gonna be dependent variable, which is Y. Okay, here we wanted to compare this to, okay, angle versus suction thickness. I want to put angle in Y, so because I think if they create something, I don't know how they create, but probably first they create that one and it has a kind of thickness, and then they measure how angle changed. So I'm gonna go through that one, okay? So I'm gonna put suction thickness as X, independent variable, and angle as dependent variable, okay? Thickness, comma, angle. I just want to make sure that I wrote them correctly. Suction thickness. Suction. Okay, I put a T extra. We don't have this T over there. Okay, something like this. That's it. Let's run this part. Let's run from the beginning, okay? Because we just opened this program. Let's run it. It gave error for correlation metric is not defined. Okay, I think I did something. Okay. Correlation. However, we don't need this previous codes. Okay, we don't need them, but I try to fix this error that we had here. Okay, now we fix it. Now I run this one. Okay, we have some result. Let's see what they are. Okay. Linear regression result. We have a slope. We just studied that and we just talked that what is a slope. A slope is that M. We have this a slope. A slope is so big here, 339. And we have this intercept as close around 3. R value, we have one R value and we have P value. We have a standard error. Okay, let's see what they are. What is R value? Okay, we know what is a slope. A slope is M. And what is intercept? Intercept is this B, but let's see what is R value, okay? But what is R value in regression? Okay, let me see. Simply put, R is the correlation between the predicted value and the observed value of Y. Okay, between the predicted value and the real value of Y. That means how accurate we are, or can be the accuracy. R score is the score of this coefficient, and in the case, the percentage of variation explained by your regression line out of the total variation. Okay, now we got it. So R, we have here R value. This R value is the difference between the real, the predicted value and the real value of Y, okay? What else we have? We have this p-value. What is p-value in regression analysis? Okay, the p-value for each term tests a null hypothesis that the coefficient is equal to 0. That means no effect. A low p-value indicates that you can reject the null hypothesis. Then it should be so small for our number. P-value, okay, p-value of 1.47, e minus 275, which it is actually so like a small value, so a small value, okay, that we can ignore it. Yeah, absolutely. Okay, p-value is that hypothesis that the coefficient is equal to 0. Okay, what else we had? A standard error. A standard error is maybe a standard how they wrote it here. STD error. Okay, STD error. Let's see, a standard error after regression. The standard error after regression provide the absolute measure of the typical distance that the data points for all regression lines. Okay. The standard error of the regression, also known as the standard error of the estimate, represent the average distance that the observed value fall from the regression line. Okay, got it. So the standard error is actually, so it comes up and create that line, okay? But it bring up a kind of average. The line is not matched exactly through all dots that we have over there. So it just create that predicted line. And absolutely it has some errors. It's not 100% like match all that points. Therefore, this is also the error that we have. If we have like a smaller, it is more accurate. It shows we are more accurate, and when it is bigger, that means not that much. So here 7.6, I think it is a kind of big error. That's dependent what kind of measurement you do and how much this number is important for you. Okay, here we just do for testing, but this is show our error, that how accurate we are. Okay, now here I have my slope, intercept, and everything. Now let's create our, I want to print out my line formula. Okay, line formula. I want to create that line formula. Before, so we know here it printed out the first value was a slope, the second is intercept and R value and that kind of things. Okay, I want to save them. I need to reuse them. Therefore, I create some variable and put it equal to this line as a slope, intercept, and that kind of things. Okay, the first value was a slope. Therefore, I wrote a slope 1, comma. I want to create some variable and put it equal that. A slope 1 and intercept. Okay, intercept 1 and R value 1 and then P value 1 and then a standard error. This was a standard error. Okay, you see here how it printed out all the result, okay, in order. So I put these variables in order. When I put it like this, it actually program recognize and understand, okay, this is slope 1 variable, consider this result, okay? And anytime that I call this a slope 1, it print out this value for me because it save it as a slope 1 here in this variable, okay, in order that I used. Now let's go and print. So I want to say print 1. What I'm gonna say my linear regression formula, okay? And I jump to the next line, \n, jump to the next line, and \t is tab. It works like tab, okay? You make an indent at the beginning of your line. And after that, I want to say y equal my slope gonna come after that, equal. Here I'm gonna say plus a slope 1, a slope 1. Okay, this is slope 1. Gonna print out this one. I try to write exactly this formula. Okay, I try to write this formula. Y equal a slope 1, whatever that I have. And after slope 1, I'm gonna put a x. Okay, x and plus b. Here we supposed to print out this plus and then b. What was the b? Intercept. Plus intercept. Okay, plus intercept. And that's it. Let's print out this one. Let's print out, run it. Okay. We got an error. Can only concatenate a string. Okay, you remember that a string things that before we learned. So here I'm gonna just use that a string function. So this is float data type. and print only accept a string data type. I just converted to a string here. Okay, how? Like this function. Do you remember this function? Like a string function like this. And here also a string function. Okay, don't forget to close parentheses should be at the end. And now it should work. Intercept. Oh, okay. Intercept is not defined. I wrote it mistakenly. So here I put intercept 1 exactly like that one. I need to wrote here intercept 1 and now run it. Okay, nice. Now I have a formula down here. Y equal 339.05 x plus 3 point something. See, now here, if anytime I want to predict the y, which was my angle, okay, I'm gonna say, okay, I'm gonna put it was, this one was suction thickness, I think so. Suction thickness, something like that. Suction side displacement, displacement thickness, suction side displacement thickness. Okay. Here, I'm gonna say, okay, I want to change this one. I want to put in 3. And instead this x, I'm gonna put 3. Now I'm gonna calculate y, which is my angle. So how my angle change. And all the time keep in your mind that we had 7% error. A standard error that we got here was almost around 7. We have 7% error, and do not forget that one at all. So here, gonna predict a value for us, okay? It's gonna predict, which is close, but with 7% error, okay? Now we got it, how we calculate and predict this one, okay? So nice. Now let's go and visualize it. Okay, now I create this line. I have this line, okay? I want to visualize it. I want to put it on a graph. How can I show it on graph, okay? Visualize linear regression. Okay, we create our formula. Now we found our formula. Here, what I'm gonna do, I'm gonna do a scatter plot. How I want to show it, see, either you can just display the line. So this is a line. This is a formula of a line, okay? And what we put instead x, I put my like suction thickness, and instead y, I put angle. And that's a line. It's gonna create a line in that graph for me. See? But here, I want to display that line and also my scatter plot of these two. I want to show you that how these dots or data on my graph is spread, and then how line, that predicted line, comes on top of it and show the result, okay? Then we're gonna create a scatter plot, plt dot scatter, okay, a scatter. Inside the scatter, I'm gonna put my x and y exactly as what we put it here, okay? X is the x that we put it here for this linear regression, and y is also same thing, okay? X was suction thickness, and y was angle. That's it, okay? Angle. And I want to add that marker. Marker, do you remember that marker? Marker. Okay, I want to have a shape of like X. My point's gonna show like X, not like O or like a small dots, okay? And I create this scatter plot. Now I have to create that line plot because I want to put this line into it. I want to put this line into it. Plt dot plot, how we were creating. line with plot function, okay? For x, so now in plot also I need x and y. But this is here, x and y is a little different, okay? My x gonna be exactly same x like section thickness, okay? And for y, I gonna put a set of data which fit my slope and intercept. Okay, see, I put x and y, okay? I put x and y, exactly that I have. But here, I need to add that a slope and intercept, okay, to create that line. So how we do, we have a formula in, we have a function in NumPy, which is like polynomial value, call it polynomial value, okay? We can use that function here. That polynomial value can come and take a slope and intercept, okay? And that's x. And with this data set x that we have here, actually we can create that line. So how we use it, I said from NumPy, np dot, we use a function called it polynomial value function, okay? Then what we pass it, polynomial function value actually need that x and y by itself too. Here as a x for this polynomial value, we can pass that a slope and intercept at the beginning, okay, like this. I'm gonna put my slope. Do you remember I said in NumPy have we use and pass the data when we have more than one? When I want to pass more than one data set, I put it in like this braces, okay? I pass my slope 1 and intercept 1, okay? And here, so this is just, oh, I'm sorry, this is just x. This is just x of this polynomial value function, okay? I put these two as a x and as a y, I gonna put this x value, suction thickness, okay, as a y for this polynomial value function, okay? Like suction thickness, and we can add a color. So I want to change color equal like red. It can be red. And what else? Here, if you don't want to this one be so like long, you can just create a variable for that one and put your variable here, or either I gonna do like this. I gonna say fit equal, I want to create this variable fit for these two, for this list, my slope and intercept, and put there, and instead this one put just fit here. Okay, I'm gonna copy paste this one there. I cut it, I put it here, and for this polynomial function, I pass it this suction fit and suction thickness. Fit instead x, which is a slope and intercept, and suction thickness is my which was here x, here sit as a y. Okay. Now let's create that label, x label, plt dot x label function, and for my x label, I'm gonna put x label was suction displacement thickness, something like that, displacement thickness as x, okay. And y label, plt dot y label is my angle, okay, my angle. And that's it. Let's run it. Okay, let's run it, see what we're gonna have here. NP is not defined. Oh, we didn't, I think, import numpy. Yes, we didn't import numpy. So I'm gonna import numpy and then run it. Let me here import numpy. Import numpy as NP, exactly like this one. Okay. Now let's run it. Okay, see. In x-axis, we have suction displacement, thickness point, and in y-axis, we have angle. So this is two graphs on top of each other. The first one is scatter for the blue dots, okay? The second one is that line plot for this red line, which is our predicted line, okay? We predict this line. This is actually our formula. This is exactly this formula, okay? Now you got it, how we use it. And this was the way that we use it. We create our regression analysis formula, we figure it out, and if we want to display it and visualize it, we exactly do it like that. So let's go a little bit and search about this polynomial value function in NumPy, okay? NumPy dot polynomial value. NumPy dot polynomial value, okay. Evaluate a polynomial at a specific values. The first one is p, that p passes if p is a length is of length n, this function returns the value of this. Okay, we don't need this formula. Okay, here the parameters that we pass to it. Parameters is important. Okay, p array like or polynomial one-dimensional object, one-dimensional array of polynomial coefficient. See, this is our coefficients that we had. What was our coefficient that we earned? Our coefficient was a slope, and a slope and intercept. So here mentioned that this p, the first parameter that need to pass is coefficients, okay? And x is a number and array of numbers or an instant of polynomial one-dimensional at which to evaluate p. Okay. That's it. And okay, this regression, I saw different types that they do regression. So this is the way that I do. There is other type of regression analysis that they do. Let me see. Regression. Okay, linear regression analysis. Linear regression function in Python. Let's see how different ways. So I'm sure that there is many different ways. That was the way that I use it. So there is absolutely different function and different way they use to see how they use. Okay. Okay, here they import NumPy, import matplotlib, and then, okay, they create a function. They create their own function, define their own function to estimate coefficient. Okay, what is the coefficient? A slope and b. Okay, a slope and b is that two important coefficient that we just figured out using this function. Okay, I just used this function. Which was the function that I used? Okay, here it is. linear regression from SciPy, but here they created, okay, they create their own like function. And they use science, okay, they calculated and they return two value, which is one of them is x and y, and they are coefficient. Probably one of them is a slope and the other one is intercept. And then they plot regression line. They create a function. We don't have this kind of function in the ready. I mean, we don't have this kind of function ready. They created, okay, plot regression, and they pass it x, y, and b. See here, they predict actually that value. Okay, nice. Here, B0 is our B intercept. See, they pass it here. They create this formula here, you see? And then B1 is that a slope. B1 is a slope that they pass it here and multiply X and then Y here. And then after that, they put it in plot. They put it in the line and create that line. See, nice. They pass X and they pass this formula, hold the formula as a Y into the plot function. Therefore, see, you can do that. We can, like, for X, we just put that X value that we had. And for Y value, you can actually pass your line formula into it. And that's it, I think. Yep. What they used here. Yes. Okay. So here they use sklearn, the linear model import linear regression. Okay, see? There exists linear regression function inside the linear model module in sklearn library. That then they use it. Let me see. Okay, the class sklearn in this line. Sklearn linear regression will be used to perform linear and polynomial regression and make prediction accordingly. See, they use different things. They use different library. Okay, function is this, exactly same, linear regression function. That's it. See, they use this. Okay, and then feed the data into it. The coefficient is R score, coefficient determination model, intercept. They print out the intercept. Okay, they called the name of the linear regression and the variable that they create for linear regression, and then keep calling intercept, coefficient, and other things. Okay, that's it. Now we learn. So I think the method that I showed probably is easier than others. And okay, we did this one. And that's it. This was the all. If we want to do exactly same thing for angle versus co-length, frequency versus sound pressure level, frequency versus sound pressure level. So let's do on frequency versus sound pressure level. The only thing that we do, we just keep changing this X and Y. That's it. That's the only thing that we're gonna do if we do on like frequency and SPL. Let me see exactly how we wrote SPL and frequency. Okay, now I'm gonna change this X and Y to frequency and SPL. Okay, I'm gonna put frequency as X and SPL as Y, and create one like regression formula and visualize this linear regression for that two attributes. Okay, frequency gonna come here. Frequency gonna come here, and then SPL. SPL gonna come here. So make sure that you do not make any mistake or missing any place that it's gonna give error to you. here, that's it. And feed the slope. Here I'm gonna pass my x, which was frequency, and then my y is SPL. Okay, marker, same thing. Here my x is frequency, and here still x is frequency. Okay, my x is frequency, and then my file label is sound pressure. Let's run it. Okay, it showed that they positively correlate. Did I like this is correct or not? I'm trying to check if this is exactly correct or not. But it shows they related to each other. So we can, yes.
Isn't that the same linear regression that we had done with the other, with the angle and the suction?
Yeah, this is exactly same thing. So
but
do
I
you,
mean,
yeah.
Isn't that the line? Because slope 1 and intercept 1.
Okay, I got you here. Here you mean?
Yeah.
Yeah, you are right. You are right. So here, I didn't run this. See, if I were running this block, so it keep up updating this slope 1 and intercept 1. Yeah, you're right. I forgot that. So I forgot to run this one to update this slope 1 and intercept 1 with this frequency and SPL, and then run it this one. Let's do that. Run this one and then run this one. Oh, yeah. See. You are right. Okay. They are negatively correlated. So here a slope is negative. Here it printed out this formula is a little negative. We can see here, this is our M, a slope, and this is B, 127. And this is exactly shape that we have, okay? And this is predicted line that we create for this frequency versus sound pressure level. And that's it. That was all about linear regression. And this was the last method that we're supposed to use. This is so commonly used in data analysis, especially in lab type of data set when we have, okay? This is commonly used for that kind of data set. If you have any question, please ask me. Otherwise, this was our last lecture. And congratulations, we finished everything.
Thank you so much. This class has been really helpful.